Hey everyone, welcome back. Thank you so much for checking us out today. It is the final AP Calc AB exam section discussion. The last two sections, we've been taking a look at the multiple choice questions, seeing some different things that can show up. We already know that any AP exam, it's kind of just like a random trivia game. You got to be prepared to recall anything from the entire year of your education. In the first session, if you didn't get to check it out, please don't forget to. We opened up with a little bit of review, some cool ways to kind of like remember what derivatives and things you need to do, how to use your unit circle just on your hand, cool little tricks. In the second session, we got further into the multiple choice. Today, do want to take a look at a couple more multiple choice, but then start doing like a little bit of a free response to show you kind of what you need to do to get the job done. I know the tests are never fun. It's probably the busiest time of your life right now. For real, I cannot thank y'all enough for hanging out with me today. Don't be shy too. Any questions are good questions. As long as we're here, we want to do whatever we can to help you. So with the AB exam, we already know like the structure of the test and what we're coming up against. We've been working through the no calculator multiple choice questions. You figure with the calculator, it's definitely going to be a friendly tool to have. You just kind of want to see what the clues are given to us in the actual test. And so what we were dealing with in the last time, we were talking about implicit differentiation. We had a couple examples dealing with limits. We got to utilize the L'Hopital's rule and just want to make sure with use substitution, at first, it can always kind of seem like a little bit of guess and check. Just want to make sure whatever you're plugging in for you, you can find the derivative in the remaining part of the expression provided to you. So if we take a look at velocity, particle, and acceleration. We know like that's the trifecta that's going on here. A particle moves along the x-axis. The velocity of the particle at the time t is given by our velocity expression. Got to find the total distance traveled by the particle from the range 0 to 6. I know I always could not stand the questions like this back in the day, for real. Never impossible. At the last class, or the last session, we were saying like, there's a point in calculus where you just kind of reach a point when you're not sure what to do, take a derivative, set equal to 0, and start figuring out your critical points. Here, well, I know it's position, velocity, acceleration. Position is a standard, your x of t. Velocity is the first derivative of the position particles, so we've got our derivative. We just now have to set it equal to 0, find our critical points. Please do be careful. Whenever you're taking the derivative here, or whenever you're setting it equal to 0, a lot of times a quick mistake can be made by not like saving and factoring. People try to reduce a t or like split apart the variables. I'm saying resist that urge. Any critical points are good critical points. So if we have our velocity function, as promised, set it equal to 0. Don't like immediately divide out a t or anything like that. We're just going to factor. They both share in common a 3, and they both share in common a t. Leaving us with, well, 3t times 4 will get us up to the 12t, minus, we already have a 3t, I just need another t. And so they're already telling me for the range from like the 0 to the 6, here we know one of the critical points is going to be at t equals 0. I can't check on both sides of it though, so we're going to see what we get for the other one. 4 minus t equal to 0 is going to make it that t has to equal 4. And so here's where you can use your first derivative test. I know I always was taught to do the number line, and you're just going to check the points that lie in between. You're going to be plugging everything in your velocity function, and you're just going to check the test value to see what's going on. Whatever's going on around those values is going to let you know what's actually taking place in your position function. And so here, we're going to label it just to make sure that we keep everything in check here. A lot of stuff happens if you leave it up here, get it down. You'll never have to worry about it that way. So going from 0 to 6, okay, kind of put the 0 there. I'm just putting like those little end brackets here just to let myself know I'm not allowed to go any further. You could use the parentheses technically. Just a way to show like you're not going to a negative and you're not going up to 7. Here, critical point at 4, I just have to study the intervals. So we're going to pick a number in between 0 and 4. If you're thinking 1, I thank you. Hang on to that thought. Here, you're just going to want to be very careful with the numbers that you're picking. Don't make your life extra crazy difficult when you don't have a calculator. So if t equals 1, actually, let me put it in the notation already. So v of 1, we're just going to plug it in to the derivative. Here, it doesn't really matter the value necessarily. You do have to pay like exact attention to the sign that you're going to be getting. So you can use your factored form if that's friendlier. You're plugging in a positive number, so your number outside is going to be positive. Inside, the number that you're subtracting is smaller than 4, so it's going to be another positive. We're throwing a big plus right here. I know I did like the increasing notation. Always helping with the summary of curve sketching. I think it's like chapter 4.5 or something when you have to find every single aspect of a graph only using calculus. Super fun, I know. No. So here, between 4 and 6, my lucky number. If we plug in 5, still no sign change in the beginning part of it. 3 times a positive, you're having a positive. Inside, though, notice the value for t is overtaking the 4. So that's how you're going to have your change in the critical point. Ballparking to the rescue. Sorry, I'm getting a little scrunched for room down there. My apologies. But here, well, now we have to remember exactly what happens. We know that we have our positive slope from 0 to 4, then it right away shifts gears. In terms of the position, though, we've got to figure out like where everything is going. Think to yourself, let our moderator know what direction is from 0 to 4, what direction is 4 to 6. Like, what does all that mean that we just figured out? Let the moderator know. We definitely know we have our critical point taking place. If we're positive from 0 to 4, well, no sign change. We're still going to be moving like to the right. So if we're positive, that particle, everything's right. And so when you take your integral, you're going to have the plus. Here from 4 to 6, though, that's where our sign's going to change. It is turning around at 4, heading to the left, which means we're going to have to make sure to account for it with the negative sign. Now we just have to set up the integral. I'm not going to distribute the negative sign into the integral. No. Negatives can get a little random at times. Save until you're ready for your final step. So if we set up our integral, we're going to have 2 of them. We know the first one, nothing big at all, our standard integration. We've got from 0 to 4 of our velocity function. Remember, we have to get the position. So 12t minus 3t squared dt. Now minus the other direction. From 4 to 6, again, the integral 12t minus 3t squared dt. And so I'm going to shift that over a little bit, just kind of clean it up for us down here. And so go ahead, perform the indicated integration. Be careful, look at your powers, making sure if you get a little hesitant about the integral when you find it, take a quick derivative in your mind. Make sure it checks out that you get back to the exact expression for your velocity. And we know with the absolute, or with the closed integral, we have to be prepared to plug them in from the top bottom minus the bottom bottom. Now be careful with that. That minus on the outside doesn't go away. Be very careful. Give it a couple seconds, then we'll compare notes. Calculus, always interesting stuff, isn't it? I like it. I'm a big math geek, though, for real. So when you take your antiderivative, should in some way, shape, or form have your function as such. You're going to leave the constant of integration out of it. Does not apply. We're on a interval from A to B. That'll be the first part that we have to evaluate. It'll be the exact same expression, thankfully. Over here, just need to be very careful about those negatives. That'll be from the 4 to the 6. Without a calculator, this could probably be the ugliest part of the question, flat out. The good news is, though, there's going to be a lot of repetition, so you only have to do calculations once for the most part, and you'll kind of have like the cool stuff start to happen. When you set it up correctly on a multiple choice test or in calculus, when the cool stuff happens, like things start canceling out, you made a good move. So if we're evaluating from 0 to 4, we're starting with the 4. Well, 4 squared, 16. I got to go 6 times that. What, 32, 64, 96. I love when the zeros show up. We are good with that first part. We're going to keep the sign out here, one negative sign at a time. So I know the 4 is going to be another 96. That'll cancel out beautifully. 6 now. We have something fantastic happening. Because we're plugging in t equals 6, you may have already noticed, it's going to be t cubed minus t cubed, or 6 cubed minus 6 cubed. Dodge that bullet big time. But if anything, just to verify with your arithmetic, without the calculator, can't get overwhelming. The 6 cubed minus, well, 6 times 6 squared, apologies, minus the 6 cubed. There it is. We did good. Minus, well, we already figured out that part, the 96, and we've got the minus the 64 we're gonna here. Like, notice how I didn't include it in the part. Like I said, when you're making the good decisions, when you made a good step, a lot of stuff's gonna go away, which is a fantastic thing. If anything, we were taking away the 4 cubes. 96 minus 4 cubes is gonna be your 32. Here, we're gonna have another 96 minus the 4 cubed. We're gonna have it go away because the 64 up top, the 64 at the end, they're gonna subtract out, thankfully. Then we just have to deal with the 96. And so, just being very careful with it. And when we're going to that, if you're taking a look, we've got our answers, definitely can't be A. We've got our 32, 64, 96 showed up about 1 billion times. Well, okay, so we've got to go with the others. The 216s went away. Let our moderator know. Are we at B or are we at C? Size. Or any questions at all, of course, fire them on in. Shorten it down there. For the distance formula, well, you want to be careful because when you're trying to figure out like the position particle of where it is when it's traveling, you have to account for both the back and the forth. Remember, it's going to be, if you're moving to the right, it has that positive position moving. If you're going to the left, you have to account for the subtraction of it. Because now here with the distance formula, you're going to use that anytime you got to find usually, well, most common application is going to be like the Pythagorean theorem. If you're dealing with the related rates, that could be an issue that could come into play where you need to calculate the distance. But then you may already know with them, they're looking at the common triples, like a 3, 4, 5, 6, 8, 10, stuff like that. Here, you want to go ahead and calculate your integral first so that you can plug in your values. I hope that helps, and let me know if additional clarification is needed with it. going to try to move this up in the cleanest way possible. I might have to hold up on that. That won't fit cleanly. So now we're doing our calculation with the endpoints. And so we already know up front, the 6 times the 16 is going to be your 96 minus 64 minus here. We had our 216 minus 216. The 6's go away forever minus the 96 minus the 64. And so up front, the 96 minus 64, we've got our 32. We're having a subtraction of a negative, so we're going to add the 32. If you have your answer C, outstanding. The tedious part of it, though, is going to be the arithmetic. Look at how beautifully spread apart the answers are. Notice as well, we were able to eliminate answers along the way. Here, we just have to be very careful that we're not assuming it. We just want to make sure that we are getting all of our work on the page. But like I said, when you have the cool stuff starting to cancel out, like we were talking about, you did good. That's always a good sign, especially in the no calculator section. But yeah, C for correct, and for this guy. Yeah, I did that. All righty. I'll keep an eye out for questions, of course. So, I don't know about you. The calculus, when you're getting into it, especially with a no calculator, you do want to be careful that you're making your time pay off. As I always keep saying, like a broken record, your time is always the most valuable commodity. You have way more control in this test than you realize. When you're in this section, if you don't happen to remember like the derivative for your number base to an exponent that's a variable, you got to kind of come back to this one. If anything, though, like I always say, we got to find the first derivative. Take a look at your answers for insight. They can jog your memory about it. Now, you're usually given your formula or your function as the number to just an x. Here, we have anything but that, so there will have to be a chain rule type situation in the first derivative. With that said, we technically could get rid of everything except the correct answer at that point. The beautiful thing about the no calculator, there usually has to be some kind of a shortcut when you're using process of elimination. If anything, you may recognize as well, A and B would be kind of like the forms if you were to do like an integral, then answer C. Definitely a nice application of a power rule, but it only works when X is your base or when the variable is your base. Your answer has to be answer D. We're gonna prove it, of course, just want to kind of show you how powerful your answers really are and provide you with tremendous insight. So f of x is equal to 3 to the power of pi x. Okay, this one really just kind of brute force memorizing it. Not at all like a heavily tested one, but when it shows up, you want to get it right. Here, you're not going to do anything at all chain rule related. You're going to apply the overall derivative first. Remember, derivative of the outside, then the inside. So if we're going to take our first derivative, still going to be the exact same function, 3 to the pi x times the natural log of 3. Yeah, right away, I'm looking at my answers. I am done at this very moment, for real. I just have to find the derivative of the pi x exponent, but already, D is the only one that's going to have the natural log of 3, the 3 to the pi x, and then the derivative with the pi. Now, don't forget to look at your answers. But the chain rule means that we have to account for it. And so, I apologize for my spacing. I don't know what's up with it today. I'm usually a lot more cognizant of that. And so, derivative of the pi x, just the pi, confirming. So yet again, it's going to be a matter of just knowing what you need to do and what you feel the most comfortable with doing on the test. They put a test in the order designed to make you kind of, well, panic, get a headache, have frustration, worry, doubt. Don't do that question first, then. You need to go and get whatever is going to be the most accessible for you, that you just know, no problem at all. And also, if you stick with the question, don't forget that future questions could provide you the insight that you need. Don't let a question lock you in place, for real. Well, let's take a look at the next one. with the whole random list of derivatives that they could bring your way. Believe me, the most important ones are usually going to be your trigonometric, the chain rule. With integrals, you're going to see one of these no matter what. Average value. I know when I was first starting with calculus back in the day, this is what I was a little bit kind of like out of it. I didn't know really what I was doing when I was doing it. I just kind of knew what I had to do. Here, average value. If we're going from 1 to e and we've got our answers as insight, well, you may remember when you're dealing with the average value, we're going to have to take the integral, but our answers kind of let us know in terms of the ordering. Remember, you always have to find the difference from your B to A endpoints. So like your A is your 1, your B is your E. We're going to be taking the difference. It should be 1 over B minus A. If I'm looking at my answers, well, right now, only D is really jumping off the page at me, for real. We'll see if we can point it out and prove it, but the answers offer you so much insight. When it comes down to it, we are going to have your average value equals 1 over B minus A. I'm just going to write the skeleton of it first in case you're taking notes and you want to recall it. And so here I'll have the 1 over E minus 1, integral from A to B of 1 over X dx. Best antiderivative ever. We've got the derivative up top over the original function. So we're going to have, is it going to be a power rule or is it going to be that natural log rule? Always be careful. This is one of the most commonly mixed up things on the test. Whenever you have your dx over x, never ever is it a power rule application. Remember how there's that little asterisk in your book? It said, you know, this is going to be the power rule except for when we have x is equal to the -1 exponent. Here, be careful. We'll have our 1 over e minus 1. This is also how you know you're moving in the right direction. We're going to be plugging in for the natural log. Well, natural log of e, best number ever. And natural log of 1, the only way they could have made it better. We'll have a 1 minus a 0. 1's the identity number. Holy cow. That was the thinking process. I can't stress enough, don't ignore your answers on this test. It just lets you know how much or how little work you have to do to get the job done. Anything with multiple choice, SAT, ACT, you name it. This is it. The AP tests are just really the only true fair test. You're actually being tested on what you learned in school, and everybody in the country is in the exact same situation. Here, well, we just have to make sure we're using the tools to our advantage. Calculus, you're remembering a lot of stuff. Let the answers help you a little bit, for real. Especially when the calculator can come into play. All right, moving on. So this one, I'm going to let y'all go with start to finish. We've already taken a look at a couple of examples like this. This is another one in which technically don't have to do any work. See if you can get aggressive with your answers and eliminate what you know is just impossible. We'll talk about it shortly. So, depending on everything you've noticed, here I'm going to show you just how to reason your way through without like throwing so much work at it. Here, well, I know I've got the outer function, then the inner function. I have to go with the chain rule, which means I'm gonna have multiple parts to this derivative. C and D stand for choose differently. I wish they would be that friendly. Chain rule, remember, with multiple choice, it's actually very friendly when you're getting the free response. That's what can overload you, but we want to use the clues. If you got to take a look at the other videos when I was talking about the trigonometric derivatives, you're going to notice the only difference is going to be with your plus cosine or minus cosine. If you got to see in that first one, the signs change whenever you're taking the derivative of a co-function. So derivative of cosine would be the negative sign. Derivative of the cosecant would be the negative cotangent. The derivative for the negative, the derivative for the cotangent is, cosecant squared. Anything that starts with the co is gonna be the negative sign flipping. That means I'm just starting with the sign. Not gonna change the sign at all. Boom, B. You can use process of elimination. Just be very careful. Don't overdo it. Don't overload. If you blank on derivatives, circle, come back. Remember, there are no walls in this section. As far as the application of the power of the chain rule and the power rule, just be careful. Kind of like look at the everything inside the parentheses as just the x. With that, y prime, if you had to find the derivative of x to the sixth, that would become 6 x to the fifth. And actually, a would be gone. So we could get it done even quicker. But we would now have to find the derivative of the inside function. And that would be with their second parentheses. Power rule, x to the fourth is going to become the 4x to the 4 minus 1, and then derivative of the sine, the cosine. Just a lot more friendly when you're looking for ways to incorporate the answers. Just let them tell you how much or ideally how little work you'd have to do to get the job done. So, well, if anything, I might go ahead and head into, well, I wanted to find like the trickier U substitution one, because U substitution doesn't always work out fantastically cleanly. We have to be prepared if we need to like rewrite any of the expressions we're plugging in. There's gonna be one of those on your test. It's one of the trickiest concepts with the U substitution. If anything here, we did talk about the tangent line in the last video. We just had to find the slope and then we used the point slope formula. Whenever you're dealing with your normal line though, remember, different. Just remember perpendicularity. The normal line is gonna be the perpendicular to the tangent line. Normal, perpendicular slope. We also saw with the implicit differentiation, don't simplify. Take your first line of your derivative and immediately plug in that coordinate. All you're going to be working through is like combining the concepts to get to your y prime so you know your exact slope. But then you just calculate the perpendicular slope of that based on what you plug in and put in the point slope form. So with that being said, it's usually question 29 or 30. Where are we at? Actually, here we are. And so, if we're looking at this, we know we've got the integral here. It might be tempting to try to like rewrite the integrand. It's not exactly in the friendliest form though. If the 5 minus 1 part of that, yeah, we could do the algebra and rewrite this and just use the power rule for integration. Here, it's that x out front and the integrand under the radical that's going to trip it. We can't do a straightforward antiderivative. We do have to apply the U substitution, but now just be careful. We're going to have to deal with the other stuff first. So we don't just have a function and its derivative. If I let you, well, people, again, it's going to seem like it's gets in check, which I mean, fact of the matter, kind of is. Here, I'm not going to let u equal x because the hard stuff is under the radical. Like that's where I'm usually going to be plugging in for my u. If we're going with that, and I take the derivative, the only problem right now should be the sign. I'll have a negative 1 dx, or just a negative dx if you're writing that, that's fine. I don't have a negative 1 in the radical. I've got the dx only, so I'm going to have to move the negative the other side through division. Now, with that, I still have that stray x value. Remember the whole beauty of the u substitution. You want to get everything in terms of the u, so then you can apply the appropriate algebraic properties, get them all, and then calculate your antiderivative. The only way I can do that, though, I got to rewrite that first equation that we plugged in for the u. So I'm going to just solve for x. Put it in a different color, make it pop. I am going to move the x over, and I'll move the u on the side with the 5, just so I don't have to worry about like dividing anything with a negative. If mistakes are going to happen, it's usually negative numbers. Just be careful. And so if I add the x to the other side, I'll have a positive x, and that will be equal to the 5 minus u. Now we have every single piece of that accounted for in the integrand. With that being said, set up the integral carefully. First thing we do, we're plugging in for the x, so we got the 5 minus u. I'm going to put that right here. We have our radical, and then our initial u that we plugged in for. When we took the derivative of the u, we ended up having to move the negative sign of the over, and we're going to have our dx, or du here, and since the negative 1 is just a constant, move it right out front. You're going to deal with it, trust me. Just save it to the end. Negatives can get bad. And it's going to help us get a little quicker through with the answers. Like already, when we start rewriting with the fractional exponents, one of these answers may start jumping out at you as being like the good answer that if you had to make an aggressive guess. Well, we got the negative. I'm going to be rewriting it. U to the 1/2 power. Remember, power over root. And so 5u, and then minus the u times u to the 1/2, u to the 3/2. Now power will to our heart's content. If anything, though, we're going to have 2 different sets of exponents. It's not going to stay at the 1/2 and the 3/2. You may already know your answer here without having to go through the painstaking process of rewriting. If anything, I can get rid of C, so I'm going to have to use a power rule, which should prove answer D immediately, constants and everything. A is the dream. Something like this, it's not going to be that cleaned up. They're missing a lot of stuff there. But no, it's just trying to get you like overdone with the power rule, or like an incorrect application of the U substitution. And then same with B. They're just trying to individualize like what's going on there, putting it everything under the radical, and then just getting it. Correct answer should be D. We'll verify. And so I have our -5 times. Remember, we're going to be doing the power rule for the integration. So it's going to be u to the exponent plus 1 divided by the exponent plus 1, or the reciprocal, times that. And then the exact same process for the u. And rather than rewriting it again, I just want to show you like how it's going to end up. All they did to simplify was get the -5 distributed, making sure instead of the u's, they're not putting the 5 minus x back in there. The trickiest part is just that stray x value or x variable up there. Like I said, when you have like a same degree expression in your radical, and then on front of it, you're gonna have to do the little side step. Just be very careful. But don't forget to look at your answers. Trust me, they give you so much insight to what you need to be doing. Remember, 75% of this test is garbage. Your job, take out the trash nonstop. Kind of curious. I know we haven't done the volume one. I was gonna do that and then hop to the free response to get like one started and walk through a little bit at least. Here, I figure volume tends to overwhelm a lot of people, whether or not be like the disc method, the shell method, the cylinders. Here, it's always going to be determined by the way they're structuring it, how you're able to create the picture, and what your answers have. If it's the multiple choice part, when it's in free response, quite frequently, they're going to tell you can set up but do not evaluate the integral. Always make sure you're looking to see what you have to do. Nothing's worse than trying to determine an overall volume you didn't ever have to do to begin with. So we have our solid generated when the region, the first quadrant, nice to know, bounded by the graph of that fantastic thing, the line x equals pi over 2, the x-axis and the y-axis revolved about the x-axis. Wow. Its volume is found by evaluating which of the following integrals. I'll give you a couple seconds. See if you can identify the process of elimination for it. That's all these ever are. I promise. Just be careful. Maybe you're able to get like 2 out of the way and you're stuck between the other 2. Make your best guess. No penalty, so you never want to leave a question unanswered. And if you do have a suggestion for the answer, let our moderator know for real. So if we're looking at our answers to focus on the differences, notice the pi, not going to help me. That's standard in any volume. I don't care about the pi. Like only that pi, actually love pi to, desserts, fantastic. Now, if we're looking at the integral, we've got the endpoints that are going on here. Well, they know that we are given the line x equals pi over 2, x-axis and the y-axis. If we're rotating about the x-axis, we need to make sure we've got the correct points that we're putting in for the a to b. And so with that, if you got rid of the 1, 0 in A and B, nicely done. You may have seen another reason to take out answer A along with another answer. All volume, when you're setting up the integrand, remember f of x quantity squared. Here, we're going to be adding, or we get the function in there. It's not going to have an outer minus an inner, not at all about that. We just got our function. And so be very careful. You do have to square it. They'll have a lot of incorrect squaring going on here. 1 plus sine squared, you'd have to use your square of the sum. We can process elimination. C is gone. D for dastardly, never. D for doable, just don't do all the work. Let the answers communicate it to you. And so when you're setting it up, process of elimination, nonstop. Just have to know the form and then look for ways to eliminate these, just brute force. All right. Lo and behold, let's hop in to free response. And so I go no calculator again, just because the no calculator, it's usually the overwhelming part of the process. You can have your calculator for the first 2 questions in this section, then you're given it like the time's up, you have to put the calculator away. You can still work on the first 2 problems, just no calculator. You can't use any of your calculator notation on those first 2 problems. You do have to establish that you're setting it up. Basically, they're going to be directly comparable to the no calculator section, just a little uglier with the numbers and the calculations, since you can type everything in there. They're going to look for the decimals. All righty. So question 3, always make sure you know how many parts you're dealing with in your free response section. You don't necessarily have to go the distance in your simplification. As long as you are equivalent and you're keeping your consistent work, adding on the bottom, you're going to be okay. But you don't want to throw unnecessary time trying to reduce and simplify. Not exactly mandatory 100% of the time. Just have to make sure that you're getting the answer on the page for what's correct. So if we have f and g are going to be our twice differentiable and functions with the table of values, I can't wait. And so going across the top, you just know you got your labels of your columns. We got our far left column are all your x values, f, f prime, g, g prime. So we've got to find the equation of the tangent line to h at x equals 2. I can't wait. So if I let x equal 2, I'm going to right away come over here, throw an arrow. Lets me know the row that I'm locking my train of thought into. I do care about every value in that row potentially, but I have to do a little bit of legwork first. Notice how h of x, they're defining it as the outer function, the inner function. Therefore, if we're going to find the equation of the tangent line, we need a slope, which means we need the first derivative, which means we need the chain rule. On with the show. And so I was just out of habit. I make sure that I copy the equation down perfectly. That way I can kind of recall if I'm writing something incorrectly. Just what I do. If it works for you, it's yours. I was just trying to say, like, resist the urge to do mental calculation. One step only of mental calculation allowed. So I'm going to find h prime. Okay, derivative of the outside. Times derivative of the inside. And then 1x equals 2. So here you just got to make sure that you're catching up or you're matching up with your lines, your columns. You see the overlap where they intersect with each other. So you're grabbing the correct values. So f prime of g of 2 times g prime of 2. And just one step at a time. Be careful when you're dealing with your functions, starting with the inside. You're going to find your g of 2, which will be that column. They overlap here, so that'll be on the inside. And your g prime of 2. There's your column. There's the overlap. And f prime of 4. So here, just be careful. Make sure you're looking at everything correctly. They do just happen to have the 4 right directly underneath the f prime of x. You're not looking there, though. The x value that we're looking for is whatever overtook the inside the parentheses. We got to hop down here. F prime of 4. Boom. Just be careful. It's a lot of follow the leader on these, making sure like when you do set up your derivative appropriately, you're just grabbing the details that you need. And notice we didn't in any way use everything that they gave to you. They're always going to overload it. Well, that's a beautiful finishing answer. And so that would be your first step. Here we already know, like more than likely going into these for the last 9 weeks, your teachers have been like providing you with practice tests, a lot of free response, a lot of multiple choice, just so that you can get as much of it under your belt as possible. Don't forget to at collegeboard.org, they publish almost every single year of your free response questions. Totally go through them. Just see like what it is. I wouldn't recommend like going crazy far back for the AP free response, but you have a lot of resources at your disposal. If you ever just want to search a year of an AP, just go into Google, type the year AP Calculus AB FRQ or free response questions, and then you can just type PDF. It should be the first link that pops up. Usually the answer key is right underneath that. Moving on. Okay, so here, well, they're kind of going the distance in testing you regarding all your powers for, or all your rules for your differential or derivatives. And so here, we already know, same intro, same table. We got to find our j of x is equal to f of x and g of x product. I'll let you go ahead, see what you can identify. One step at a time. Don't overdo it. Trust me. If you're going to commit to a part, that part needs to pay off in your favor. Go a little bit longer. There's a third function involved. It normally is chain, not inverse. Depending on how you're structuring it, usually I think you might be thinking about the -1 power. They would usually have to clearly state that out. With this though, you might be referencing the third function as the J, the new function that they are using to define it as just the product of the other two functions. So I think if I'm understanding your question correctly, it would just be about making sure to see what they're asking of you. Doesn't necessarily mean that you're dealing with an inverse at all. The inverse usually has to have the hypers or superscript of the -1, but then you still want to make sure that's not just a reciprocal down below. It really would be a question by question. I can't definitively say one way or the other if it would be. I wish I could. It truly does depend on the question. Let me know if there's something that I didn't understand, or if there's something you had in mind specifically. And so here with the J function, definitely naming the product of the F and the G. So we do have to use the product rule. Be careful, one thing at a time. The ordering of the derivatives doesn't matter with the product rule necessarily, like it does with the quotient rule. Here, just don't do the derivative in one step. It's always going to be the one thing plus the other thing. Derivative of the first times the second plus derivative of the second times the first. And now it's just going to be the follow the leader yet again. Your x is going to equal to 3. I've already got the arrow out there. I just have to find one little thing at a time. And so f prime of 3 will be up here. They overlap at the 2. G of 3 minus 1 plus g prime of the 3. And now we're going around the world with them. And so, and then the f of 3. And that'll do it for us. And so, I mean, technically, you should be able to just leave it like that, depending on if they provided your make you simplified all the way. Just say timing is always a thing on these tests. There's nothing wrong with that arithmetic, and that is your answer. If anything, when you're checking the answer keys, if you are researching any other free response, they're going to let you know exactly how they provided the scoring criteria, where you get the 1 point, the 1 point, the 1 point for each individual component in a part. If you did do the arithmetic, you're going to have your -2 plus the 15. The lucky number 13. Not an unlucky number. It's a decent number. Remember one thing about this test, the calculus is not going to be the problem. It's the 50 billion steps of algebra. If everything that you've done in your year preparing for this, everything in your textbook, in school, that is all of the hardest stuff you're ever going to see. If you felt okay with that, just remember to breathe during the test. Don't overload yourself. Don't kick yourself. Nothing like that. No, you've done a tremendous amount of work going into that for this year. You've already seen the worst of it. I promise you that. Just don't forget multiple choice. Look for ways to incorporate your answers. only do what you have to do in the free response. If you get stuck on a part, move on. Don't like just leave everything like blank. No, let's say like you got your product rule or derivative here, just kind of like lost a little way. You're still going to get partial credit. Like they're going to want to see the correct breakdown of the derivative. Like that'll be a point. And then you're plugging in your 2. Each value, that'll be either another 1 or 2 points. Just about knowing what you have to do to get the job done, my friends. And kick some butt. Did a lot of good work. You want to pay off. I will be checking these videos again. I can't thank you all enough for like hanging out with me. I know it's never a fun part of the year, so thank you so much for spending the time with me. It's the most valuable commodity on the planet during this time. One thing at a time, my friends. Breathe. You got this. I'll be checking back with the video too. If you have any questions, you can absolutely post them in the comments section. I will reply with them always as quickly as I possibly can. Again, thank you all so much. Happy prepping. And kick some AP butt. You got this.